Algebra 1 students, welcome to your 2.2 notes, solving two-step equations. We learned how to do the one-step equations. Now we're going to learn a two-step dance. Here we go. A little bit of review from section 2.1. Inverse operations are operations that undo each other. And we want to undo our operations in the reverse order. So if you remember, the inverse of addition is subtraction, and the inverse of subtraction is addition. And then also the inverse of multiplication is division. And the inverse of division is multiplication. So, in order to do our two-step equations, for number one, let's take a look at why they call it a two-step equation. We're really not learning anything new as far as what we need to do. We're just taking more steps to get there. So basically, we're still going to solve for x. Here we go. Let's start by subtracting 5 from each side. And that's going to leave us with 3x is equal to 15. All right. And then we're going to go ahead and do our second step. I'm going to do our second step in red so you can see the entire reason why it's called a second step. No trick to it at all. You just divide by 3 to isolate that x right there. All right. And then we're going to end up with x is equal to 5 in that case. All right. Number 2. We have x divided by 4 minus 2 equals 8. All right, so let's go ahead and add 2 to each side. Okay, so we're going to end up with x over 4 is equal to 10. Okay, and then our second step that we're going to do is we're going to multiply each side by 4. So let's multiply each side by 4 with a red pen there, so we can see why we did that. Okay. 4s are going to cancel out, which leaves us with an x isolated all by itself. We have x is equal to 40. All right. That's all there is to it. Let's move on. Okay. Several of you after that first slide are probably working really quickly to get ahead of me. So let's go ahead and do number 3. All we need to do is subtract 6 from each side. Okay, we're going to be left with a negative x equal to 3. All right, well, what is negative x? Negative x is the same as saying that we have a negative 1 sitting right out there in front of it. Okay, that's the way that I like to think about that anyways. So I'm going to go ahead and divide each side by a negative 1 in order to get rid of that negative 1 and isolate that x. All right, so when I do that, I'm going to end up with x is equal to negative, that's supposed to be a negative. It's supposed to look good, so let's get some erasing air. Negative 3. All right, let's move on to number 4. Okay, the first thing that I'm going to do on number 4 is I'm going to multiply each side by 3. All right, so here's the way it's going to look. X plus 5 divided by 3 times 3 is equal to 10 times 3. All right, so when I do that, on my left hand side of the equation, my 3's are going to cancel out, right? And then I'm going to be left with this x plus 5 sitting here. That's equal to 30. Then I can go ahead and subtract 5 from each side, and my x is going to be equal to 25. All right, let's move on to our application problems that we have for section 2.2. For number 5, we have Susie has $26 and a coupon for $2 off at Best Buy. A CD costs $3. How many CDs can she buy? So the phrase right here that says how many CDs, I'm going to go ahead and underline that because that's going to tell us what our variable is going to be. Okay, so I'm going to leave this in red. X is going to be equal to the number of CDs. Okay, so since X is equal to the number of CDs that we have, that helps us set up our equation. All right, since we're looking for the number of CDs and we know that they cost $3 a piece, we're going to have 3X, and then we need to account for this little $2 off coupon that she's got. Okay, so she can spend a total of $26. And now we have our equation set up. Okay, so this looks a little bit like our two-step equations now, so we can figure out what to do with it, and I'm sure most of you have already started working on it now. Okay, so we can add 2 to each side, all right, which leaves us with a 3x equal to 28, okay. And then the next thing I'm going to do is divide each side by 3, okay. All right, so when I divide that out, okay, we divide 3 by each side, and we're going to have an x equal to 28 over 3. When I divide that out, I'm going to basically have $9.33, okay? Or actually, that's going to be about 9 1/3 CDs, and that's not the dollars, sorry about that. So we've got 9.3 CDs. Well, we're really not going to be able to go to Best Buy and say, hey, I'd really like to have you break a CD so that I can have 1/3 of it. They're not going to tell you that. So the answer to this problem is she can buy 9 CDs. Okay, Frank is going bowling, and shoe rental costs $3, and each game costs $2.50. Frank has spent $12, or Frank has $12 he can spend. How many games can he bowl? Okay, so this right here, how many games, that's going to be our variable. So we're going to say that X is going to be equal to the amount of games he can play. Okay, we do need to know a little bit about bowling here. You're going to have to pay the $3 for shoe rental no matter how many games you play. All right? And then each game is going to cost $2.50. So we're going to multiply that by the number of games he's going to play, which is our variable right there. Okay? So boom. And he has $12 that he can spend. Okay. I want you guys to pause the video and do this work because you know how to do it once you get to this spot. All right, so here's the work that I have for number 6. I subtracted 3 from each side to try to isolate that x. Then I ended up with 2.5x equals 9. My next step was to divide each side by 2.5. And then when I did that, I reduced that and got 3.6. Well, usually at the bowling alley, kind of like the problem with the CDs, usually at the bowling alley, they're not going to let you roll just a couple of frames. They're going to make you pay for the whole game once you've started. So he probably needs to stop at the end of 3 games. Otherwise, he's going to have to do some work for him to pay off that game. Okay, so for number 7 and 8, we're going to use something called deductive reasoning. In math, it's one of our ways to use higher order thinking. And what we're going to do is we're going to actually complete each step. But we are going to, when we do that, we are going to justify each step. So it's not just actually completing the math. You're going to have to actually explain or defend what it is that you're doing. And so here we go. When I take a look at number 7, the first thing that I see that I'd like to do is I'd like to add a 7 to each side of the equation. And before I do that, I actually need to talk about the very first line of information, which is the equation that they gave us. That line is given to us, okay? So that line is given to us, all right? So here we go with that information. That information was given. All right, I think you guys grasp onto that. So the reason that we can add 7 to each side is because of the addition property of equality. All right, so the addition property of equality, and we end up with 3x is equal to 21 after we do that step, okay? So next, we're going to go ahead and divide each side by 3. You guys are pretty okay with that particular step. We end up with x is equal to 7. And the reason that we were able to do that step is because of the division property of equality. All right, so I think you guys get the picture. In number 8, I'm going to go ahead and actually start with the given information this time. So I'm going to go ahead and write the first step as being given. And then the second step, what we're going to do is we're going to subtract 4 from each side. So I'm going to go ahead and take that out. And we're going to be left with 7 is equal to x over 5. Why can I do that? Well, because of the subtraction property of equality. All right, the subtraction property of equality. So the next step that we want to do is we want to multiply 5 times each side of our equation. And so when we do that, we're going to end up with, don't want to move stuff here. We're going to end up with 35 is equal to x, and that's because right up here we multiplied each side by 5, okay? And then we did that into this step. So the reason that we can do that is because of the multiplication property of equality. All right, so the multiplication property of equality. So that's the reason we're able to do that final step there. So that actually concludes today's notes. Please come to class ready to work hard and figure out how to do the practice problems. We'll see you soon.